This tower in Norway, this proposed skyscraper in Australia, and this school in the UK all have the same thing in common. They're all being built with timber taken from sustainably managed forests and engineered in a factory like this. It's the material we've built with for thousands of years, but after some major fires and then the advent of steel and concrete, the Industrial Revolution and the birth of skyscrapers, it fell from favour and was rarely seen outside of house building. But that's all changing. The old problems of strength, fire and deforestation are all being answered. The old excuses for not using it have fallen apart, and our planet stands on the edge of a climate catastrophe, partly brought about by our reliance on unsustainable construction materials. It's time to change this. It's time we built every building with timber. So you're probably freaking out about now. We've just said that every building should be timber and advocated chopping down trees to make buildings that are flammable, right? Well, on the trees and fire part, wrong. To really understand this material and why it's exactly what we need right now, you need to understand how it's made and used in a short but comprehensive video. Here we go. First off, wood comes from trees, and only when it's been made into planks, beams or some kind of structural element is it then known as timber. Any reputable timber construction company will now get its wood from a sustainably managed forest. This is where more trees are planted than harvested, a practice now widespread across our planet and especially in Europe. We don't endorse anyone getting their timber from a forest that's not managed like this, and neither do solid timber specialists like Eurban.
Sustainability is a really important thing for us in the timber industry because we are relying on the resource. If we cut all the forests down now and not replanting it, we don't have any work in a few years' time, or the next generation will not have the joy using the forest as a leisure part of their life, but also for building materials.
As well as making sure we don't run out of trees, it's also a key weapon in our fight against the changing climate, as trees are able to absorb carbon dioxide and store it inside their wood. Our buildings account for about 40% of all greenhouse gas emissions, and constructing them in timber would help to reduce this figure. In fact, carbon emissions savings of around 60% can be achieved, and 400% more carbon can be stored within a timber building than a concrete one. You have to remember that the processes for producing concrete and steel are highly unsustainable and do significant harm to our planet. Growing and harvesting timber this way is actually beneficial, and the benefits would only grow if we built with it on a mass scale. Also, as trees age, they begin to absorb less CO2 and produce less oxygen. Therefore, harvesting them once they're mature and planting new ones in their place can, in some areas, actually be better for the environment than doing nothing. The other thing to point out is that the trees aren't cut down by a burly chap like this who's probably called Jack or Chip. They're carefully selected and increasingly felled by machines. Once cut, the wood is transported for processing, often in a location close to its source. Preparing raw timber for construction used to be a time-consuming manual task, just ask Chip, but today it's mostly done by machines in automated factories. Parts can be made quickly in almost any size or shape for any project. Large elements like walls, floors and even whole sections of a building can be made in factory-controlled conditions before being transported to site. Once there, they're assembled on pre-built concrete foundations. It's quieter, faster and safer than other building techniques.
We're not just using timber planks which are coming out of the forest and just sawn. Mass timber and engineered timber in general is a great innovation we have seen over the last few years. This allows us to build higher, bigger and in better quality than ever before.
Modern wood types like cross-laminated timber known as CLT and laminated veneer lumber or LVL enable whole buildings to be made out of wood, from the structural beams to the walls. CLT panels are made by fixing several lumber boards together in alternating layers using super strong adhesive and compression techniques. Doing this gives the material high strength in two directions, making it sturdy and versatile. Another kind of engineered wood known as glue-laminated timber or glulam is made using a similar method, except the layers all face the same way. Glulam's therefore ideal when strength is only needed in one direction, like with a column or a beam. Due to its light weight, mass timber can be engineered to be stronger than steel pound for pound, and because of its added seismic resistance, CLT performs impressively in areas prone to earthquakes. Height's also no longer the issue it once was, and timber buildings over 80 metres are already completed or under construction in Europe, North America and Australia. Though still dwarfed by some of our biggest steel and concrete skyscrapers, growing expertise, improved R&D, pressure to build sustainably and the easing of height restrictions is quickly changing this. Whole timber districts are now appearing in several cities. We can achieve the spans needed to build airports, train stations and bridges. The proven well-being benefits are making a difference in timber schools and hospitals. And one football club in the UK has gained approval for the world's first all-timber stadium.
We are pushing boundaries here. We see all kinds of new buildings, bigger buildings, really special buildings happening in timber. And that's the great thing. We have sparked the imagination of designers.
While that may be so, the prospect of building every building with timber can instinctively raise concerns, especially when it comes to fire. Now, all buildings carry the risk of fire, but timber buildings can be made to burn in a much more predictable way than those built from steel and concrete, and can be designed to be even safer. Engineers can now design timber buildings to burn for specific periods of time. They remain standing for long enough to meet the regulation escape times, normally an hour or more.
Traditionally, we knew very little about timber and therefore our designs were super conservative. So we were using huge safety factors because we knew little about timber and we were not optimizing our designs.
Carmen Gorska is a research and development fire safety engineer at renewable materials company Stora Enso.
It's about the quality of the design, and the design should just take into account how each material is going to behave when there is a fire. So steel is going to bend much more than timber. Timber is going to burn and char, and concrete is gonna spall, for example. So it's just about understanding with what material we are dealing with.
Timber structures can be fitted with sacrificial layers where an outer section takes the brunt of the damage and chars at a predictable rate in the event of a fire. Softwoods like the ones used here can char at a rate of less than 1 mm a minute, protecting the inner segments and allowing time for evacuation.
Today, the most current practice is to protect timber with plasterboard sheets. So normally we know how long the fire is going to take, and we just adjust the amount of layers and the thickness of plasterboard layers that are going to protect the wall behind from the whole duration of the fire.
Timber buildings can be designed for self-extinguishment too, which is when flames are no longer strong enough to break down the material and the fire dies out due to a lack of fuel. The modern timber used in many large-scale buildings like apartment blocks and that proposed stadium is also treated with fire retardants which prevent the spread of flames on the material's surface. Moisture and the threat of mould is another issue that mass timber has tackled. Although water can't be entirely removed, CLT is kiln dried to bring moisture content down to around 12%, enough to prevent fungal attack and kill off any bugs that might be lurking inside. If all of these benefits weren't enough, timber also looks pretty awesome, and architects are creating some incredible buildings, especially by leaving the fire-treated material exposed. Of course, building with timber can't eradicate our use of other materials. We still need concrete foundations, and some buildings are often hybrids of timber and steel, but it would make a massive difference to the process of construction. Things would be quicker and quieter, the end result would be better for our mental health and well-being, and we'd be generating far less pollution along the way. The mass timber industry is seriously scaling up at exactly the same time as our need to build more buildings quickly in a higher quality way that doesn't harm the planet. The benefits are pretty hard to ignore, and going all out with wood is becoming a no-brainer for many construction companies and their customers around the world. It's no longer a question of why would you build with timber, but why wouldn't you? We have the ability and the business case to build all of our buildings like this. The examples and the potential is all there, and an entire generation of muscular lumberjacks could be understood and appreciated for the brains it took to craft this advanced process, not just their brawn. If you liked this video and you want to learn more about where construction is headed, make sure you're subscribed to Tomorrow's Build.